In this video, we'll look at the syntax for accessing individual vector elements. The first way to access vector elements is to use the array syntax we've already learned using the subscript operator. That's the square brackets. We use the name of the vector followed by the square brackets with the index of the vector element we want inside the square brackets. For example, test score sub 1 refers to the element at index 1 in the test scores vector. In the code example at the bottom, you can see that the syntax is exactly as it was for arrays. Remember that vector subscripting or indexing is the same as in arrays. It starts at 0, so the first element of an array is at index 0. It's important to understand that when we use the subscript operator with a vector, no bounds checking will be done. You have to do it yourself, as with arrays. Now let's look at another way of accessing vector elements. We can also access vector elements using the @ method. This is the vector syntax. Since when we create a vector, we're really creating an object in object-oriented jargon, then we can ask objects to perform operations. These operations are called methods. The syntax is simple. The object name, in this case the name of the vector, followed by a dot called the dot operator, followed by the name of the operation we want performed. This is the method name. Don't worry about the jargon for now. It will come before you know it, and we'll cover it in depth when we talk about object-oriented programming. The C++ vector has a method or operation called at, so you can ask the vector to give you an element at a specific position, which you provide inside the parentheses. This style is actually much more intuitive since the name at provides context. So in the example, we've declared and initialized the vector named test scores to the 5 integers 100, 95, 99, 87, and 88. If we want to access a specific element, we use the @ method and provide the element index. You can see that the syntax is very easy to read and understand. Test scores at 0 will refer to the first element in the vector. That's element at position 0. We can also use the same syntax when we want to modify vector elements. In this example, we're reading 5 integers from the console and storing these elements into the test scores vector. The last statement is an assignment statement, as we saw with arrays. We're storing 90 into the first element of the test scores vector. You're probably thinking, okay, that's pretty easy. Vectors are just as easy to use as arrays, but when do they change in size dynamically? The vector has a method called pushback that adds a new element to the end of the vector. Remember, all vector elements must be of the same type, so the element you add must be of the same type as all the other vector elements. In this example, we've created a vector called test scores that contains 3 integers, 100, 95, and 99. If this were an array and we wanted to add another test score, we'd be stuck since arrays are fixed in size. However, with vectors, we can use the pushback method and provide the integer you want to add within the parentheses. You can see that I'm asking the test scores vector to push back 80 and then 90. This will add 80 and then 90 to the end of the vector. Now the vector will contain 5 elements, 100, 95, 99, 80, and 90. How does this work? You don't have to worry about it. That's the beauty of vectors and of the other classes in the standard template library. The vector will take care of allocating or deallocating space, adding new values to that space, and so forth. You can concentrate on solving your problem. Okay, but what happens if you're using at or some other vector method and you go out of bounds? Let's see. If you go out of bounds and you're using a method that does bounds checking, C++ will throw an exception. That's the jargon used to say that an exceptional condition has been encountered and the program can't continue. An error message is displayed and the program will terminate. This is a good thing. Now you have an error message that tells you what the problem was and you can fix it. The error message in this case is pretty long, but it's telling you exactly what happened. The error message may look different depending on the compiler you have, but the information provided will be the same. In this case, I bolded the important parts of the error message. You can see out of range, vector, range check, and the numbers 5 and 2. When you look back at your code, you'll see the vector has 2 elements and you want an element at index 5. You want your program to terminate or crash during testing so you can fix errors, but you don't want it to crash in production. This is where you can do exception handling. This involves catching these exceptions as the program runs and dealing with them so that the program doesn't crash. Exception handling is a more advanced topic, but I want to cover the basics, so there'll be a section at the end of the course just on exception handling. I hope you can see how much better vectors are than arrays and why you should use vectors in modern C++. Now let's head over to CodeLight and use what we learned and write some code with vectors. So now I'm in CodeLight, and let's do some examples with vectors. I'm in the 7-section workspace under the Vectors project. And here's my main file. Notice that I'm including the vector include file. You must do this in order to use vectors. Also, vectors belong to the standard namespace, so either you use the namespace standard or you'll have to do std, scope resolution operator, everywhere you use vectors. Let's talk about a couple of different ways to create vectors. In this first example here, I can create a vector called vowels, and it's a vector of characters, and that's the syntax. We put the type inside the angle brackets. Okay, so in this case, I've got vowels as a vector of characters, and this is an empty vector. Okay, it's of size 0. There's nothing in there right now. The only way to add things to it is to do something like push back, which we'll do in a little bit. The second example creates a vector called vowels again. In this case, it's 5 characters long, and each one is initialized to 0. This third example here, which is the one I'm going to use in this example, I'm using an initializer list here, so I'm initializing the vector vowels, which is again is a vector of characters, to the characters A, E, I, O, U, which are my vowels. Again, remember that the character literals have single quotes around them, not double quotes. So at this point, I can simply output vowels sub 0 and vowels sub 4, which I expect to print out A and U respectively. Notice that even though I'm using a vector, I'm using the array syntax, so it's very, very familiar. Also remember that using the subscript notation does not do bounds checking. Okay, so let me run this. So there's my sample run, there's my lowercase a, my lowercase u, just what I expect. All right, so now let's take a look at another declaration of vector. In this first example here, I'm creating a vector called test scores, which is a vector of integers, and I'm creating a vector of 3 integers in this case. All of them will be initialized to 0. In the second example, I'm creating the test scores vector again. Obviously, I have to comment them out. You can't use the same name twice, that's why I'm doing this. It's a vector of integers, 3 of them. Each one is initialized to 100. And so those are 2 variants for constructing these vector objects. The one I'm going to use is this one right here, where I'm saying test scores, again, is a vector of integers, and I'm initializing them to 100, 98, and 89. So in this case, I'm going to get exactly 3 elements in my vector. My vector will be of size 3. Okay, so let's comment this out here. And in this case, I expect it to display 100, 98, and 89. Again, here I'm using the array syntax. So let me run this. And there you go, 100, 98, 89 using array syntax. Now we can also use vector syntax. So let me uncomment this. And now here you can see I'm saying test scores dot at 0. Test scores at 1, test scores at 2. So in this case, I'm using the at method to give me the value at that specific index. Same idea, except that this is a method and this will be bounds checked, which is very important to understand. Also, after I print out those 3 numbers, I'm saying there are so many scores in the vector. Okay, so what does that mean? Well, notice the size method here. This is a method in the vector class. So I can have my vector name, and I can just say something like dot size. It's that simple. And this will return however many items are in the vector right now. Right now, I have 3 of them. So I expect this to say there are 3 scores in the vector. Remember, the vector can grow and shrink dynamically, so it's important to be able to ask it, hey, how big are you? And that's what the size method does. So I'll run this one more time. And you can see here, my test score is using array syntax 198, 89. Now my test score is using the vector syntax 198, 89. We expect that because the vector hasn't changed. But here it says there are 3 scores in the vector. So here we're asking the vector, hey, how big are you? What's your size? And it's returning a 3. In this example here, what we're going to do is we're going to actually put some information into the vector. We're going to use the vector syntax from this point forward. So here, I'm saying enter 3 test scores, and then I'm grabbing 3 integers from the console, And I'm putting the first one at 0, the second one at 1, and the third one at 2. So I'm changing those vector elements. And then I just want to display them out again. So I'll uncomment this. Okay, so let's do that. I'll build and run again. Right now we've got 100, 98, and 89 in there. So let's just say I want 10, 20, and 30. And I want to display them out. And there you go. Updated test scores is 10, 20, and 30. So you can see that we've actually changed the contents of those vector elements. Now let's talk a little bit about the dynamic nature of vectors. This is the part that's really, really cool. I'm going to uncomment this bit out here. And notice the code here. It says, enter a test score to add to the vector. Remember, the vector at this point has 3 elements in it. I need to read this into some variable, so I've created a simple variable right here called score to add. It's just an integer. This is not a vector. This is not an array. This is just a plain old integer variable. I'm initializing it to 0. That's the best practice. And I'm reading an integer from the keyboard, from the user, and putting it into score to add. Then what I'm going to do is I'm going to tell the test scores vector to push that integer at the back of the vector. So it's going to add it to the vector. If the vector needs to increase in size, it will. That's nothing we have to do. It handles that automatically. Then I'm going to say enter one more test score. So I'll read another test score from the console and I'll push that score on. So at this point, when we display, we should have 5 integers now in the vector. I'm going to display them all at 0, 1, 2, 3, and 4. And then I'm going to say, hey, test scores, what's your size? And I expect a 5 here. Okay, so let's try that. All right, so I'm going to enter my test scores again. I'll say 10, 20, and 30. Now, remember, our vector contains 3 integers right now, 10, 20, and 30. So let's enter a test score to add. Let's add 100. Now it's saying, give me one more. Let's put in 105. Maybe I got some extra credit. Now when I press enter, I should expect to see 5 integers displayed, as well as the size of the vector now being 5. So I'm going to press enter, and that's exactly what I see. The test scores are 10, 20, 30, 100, 105. Then it says there are now 5 scores in the vector. That's pretty cool. Let me show you an example of an exception. Right here, I'm saying this should cause an exception because I'm trying to access test scores at 10. If I tried to do something like this and just used array syntax, like that, no bounds checking will happen. I might just get a crash with no error message or anything. Instead, I'm actually saying at 10. And we could try to put a new line. It's not going to matter much because it's not going to do that because there is no 10th element. Let me run this again and I'll enter those numbers again. Okay, so again, we'll say 10, 20, 30. Let's push in 100 and 105. Now we should get an exception, and there's the exception. You can see the program is still stopping, but there's my exception. Terminate called after throwing an instance of out of range. There's a range checking problem, which is at 10, and this guy is 5 big. So that gives you a really, really good clue as to what's going on. All right, I'm going to comment that out so it won't affect us again. And then the last thing we'll do is I'll show you an example of using a 2-dimensional vector. I'll uncomment all of this out. All right, so here, how do we declare a 2-dimensional vector? Well, a 2-dimensional vector is a vector of vectors. So it's a vector of vectors. And this is how I would declare a vector of vectors. I want to declare a vector that contains within it not ints, not floats, not doubles, but a vector. In this case, a vector of integers. And that's my movie ratings. I can initialize them right here. So going horizontally, that would be the first reviewer, the second reviewer, the third reviewer. And going vertically, this would be the first movie, the second movie, the third movie, and the fourth movie. Now, just like I showed you in the slides with arrays, I can use array syntax. So I could say here are the movie ratings for reviewer number 1 using array syntax. And I would expect this to print out 1, 2, 3, 4. That's the first reviewer right up here. And in order to use vector syntax, we just use at, but we use it twice. Give me the rating at 0, that gives me this guy. And then once I have that guy, I can take at 0 for him, or at 1 in the next line, and so forth. So if I run this, I would expect to see 1, 2, 3, 4 both times. So let's run it. And we'll get by this part one more time. And there you go. Here are the movie ratings for reviewer number 1. Array syntax, 1, 2, 3, 4. Here are the movie ratings for reviewer number 2. That should have, sorry, number 1 again. That's right. Using vector syntax, 1, 2, 3, 4. Okay, so that basically covers the fundamentals of vectors, how to use them. There's so much more to vector, and we'll talk about all of that when we talk about the standard template library. But congratulations, you've just now created objects, used object methods, and we're on the way to object-oriented programming.